Have you ever wondered how ChatGPT can write code, solve math problems, tell stories, and answer almost any question? What if I told you that behind all of that intelligence is one surprisingly simple task, predicting the next piece of text? In this video, we are going to uncover how large language models generate responses, why they sometimes make mistakes, and how a simple prediction loop powers modern AI. Let's dive in. Most people imagine AI works like a human. You ask a question, the model thinks deeply, then it produces a complete answer. But that's not what actually happens. Instead, the model predicts one token, then another token, then another. And by repeating the process thousands of times, a complete response emerges. Everything you are reading from an LLM is generated one token at a time. So what exactly is a token? A token is a chunk of text. Sometimes it's a full word. Sometimes it's only part of a word. For example, the sentence artificial intelligence is amazing gets broken into smaller pieces called tokens. Language models don't see letters or words the way we do. They see streams of tokens. And every prediction they make is really a prediction about what token should come next. Now let's see what prediction actually looks like. Imagine the sentence. The capital of France is. The model doesn't immediately answer Paris. Instead, it assigns probabilities to every possible token in its vocabulary. Paris might get 96%, London 2%, Berlin 1%, and everything else gets tiny probabilities. The model then samples from that distribution and chooses a token. This probability game happens for every single token it generates. But how does the model learn these probabilities? During training, it sees enormous amounts of text. Imagine the sentence, the cat sat on the blank. The model tries to guess the blank, that is the missing word. Maybe it predicts chair, but the correct answer is mat. That difference creates an error called loss. Using backpropagation, the model adjusts billions of internal parameters. After repeating this process trillions of times, it becomes better and better at predicting the next token. Early large language models, or language models simply, had a major limitation. They processed text sequentially and often forgot information from the beginning of a sentence. Then came the transformer architecture in 2017. Transformers allowed every token to look at every other token simultaneously. Instead of remembering only recent words, the model could access the full context at once. This breakthrough is what made modern LLMs possible. The secret ingredient inside transformers is attention. Attention determines which words matter most for a prediction. Take the sentence, the Eiffel Tower is located in. When predicting the next word, the model pays far more attention to Eiffel and tower than to words like the or is. Each token effectively votes on how much influence it should have. The strongest signals guide the prediction. Now the magic starts happening. Suppose the prompt is explain gravity in one sentence. The model predicts the first token. That token gets added to the context. Then it predicts the second token, then the third, and so on. Each prediction becomes part of the input for the next prediction, one token at a time. An entire sentence forms, then a paragraph, then a complete answer. If the model is so good at prediction, why does it sometimes make things up? The answer is simple. The model always has to predict something. When it's operating inside familiar territory, its predictions are usually accurate. But when information is missing, uncertain, or outside its training data, it still generates tokens. The result can be a response that sounds convincing, but isn't actually true. That's what we call hallucination. Not every prediction uses the same level of randomness. That's where temperature comes in. Low temperature makes the model choose highly probable tokens. The output becomes more predictable and consistent. Medium temperature balances reliability and creativity. High temperature flattens the probability distribution, allowing unlikely tokens to be selected. This can produce more creative responses, but also more chaotic ones. At its core, an LLM runs the same cycle repeatedly. Take the prompt, run a forward pass, predict the next token, append it to the context, and repeat. There isn't a giant answer hidden inside the model waiting to be revealed. There is only this loop running again and again at incredible speed. Thousands of iterations create the illusion of continuous thought. And that's the amazing part. Code generation, reasoning, translation, storytelling, planning, math, even AI agents, all of these capabilities emerge from one repeated question. What token comes next? A simple prediction task scaled to billions of parameters and trained on massive amounts of data becomes one of the most powerful technologies ever created. If you enjoyed this breakdown, hit the like button and subscribe for more such deep dives in AI, machine learning, and how modern models actually work. Let me know in the comments which AI topic you would like explained next. Thanks for watching, and I'll see you in the next one.